Okay, so this is our second video on quadratic functions, and what we're working on right now is we're in the middle of a 3-video series on how to create a graph for a quadratic function. Okay, so this is the second video, the middle video in that series, and basically what we're doing is we're looking at the different parts and pieces of the graph and how you find each one of those pieces, and then at the end we'll put them all together to make the graph. Okay, so with that said, let's just jump right into our learning objectives and talk about what we're going to do in this particular video here. So you can see that what we're talking about in this video is how to find intercepts, the x and the y intercepts both, for a quadratic function. Okay, and so I want to begin just with a quick reminder of what we talked about in the last video, the different parts of the quadratic's graph. Okay, so the graph, this red curve right here, is always going to be the general shape of a quadratic function. That's called a parabola. And the parabola has basically 5 different features that we're talking about in these videos. In the last video, we talked about concavity, whether the parabola is opening up like this one right here, or opening down, right? So this is a parabola that opens up, and this is a parabola that opens down, okay? And so we talked about how to figure that out. We talked about the vertex. If the parabola opens up, the vertex will be at the very bottom of the graph, exactly in the center. And if the parabola is opening down, it'll be at the extreme top of the graph, again, exactly in the center. So that's the vertex. All parabolas are symmetric, so they have a line of symmetry, and we talked about in the last video that that line of symmetry will always pass exactly straight through the vertex. And it's a vertical line when we're talking about quadratic functions, okay? So those are the 3 things we talked about last time: concavity, line of symmetry, vertex. We talked about those last time. And as we saw in our learning objectives, this time we're going to talk about x-intercepts and y-intercepts. Okay, now, before we actually get into finding the intercepts, I want to talk about a couple different things that could happen. So here I've got 4 parabolas that I've drawn, and I want you to notice a couple things. The first thing I want you to notice is every single parabola has one y-intercept. Okay, so this one has a y-intercept right there. This one right there. Remember, y-intercept is where the graph is touching the y-axis. That's the definition of a y-intercept, where it touches the y-axis. And every parabola is going to have exactly one. And if you think about it for a minute, you should be able to explain why. First of all, quadratic functions are functions, which means they have to pass the vertical line test. And in order to pass the vertical line test, a parabola could never, ever, ever have more than one. It could never have more than one y-intercept. Otherwise, it would fail the vertical line test, because the y-axis is a vertical line. So if it touched it more than once, it wouldn't be a function. But it'll also never have less than one, because notice our parabolas, every single one of these parabolas, they leave our graphing region and expand out into the rest of the graph at some slight angle. So some of them might be a fairly wide angle like this one. Some of them might be more steep. Some of them might be very steep. It might, be just very, very steep like this. But they all leave at some angle. And if they leave at some angle, that means they're eventually going to go all the way over to the right, and they're eventually going to go all the way over to the left. And so no matter where the bottom or the top, wherever the vertex of the parabola is, eventually, sooner or later, it'll hit the y-axis. Okay, so you might think a little bit about, in our discussion from before in our class, the concept of domain and range. The fact that this parabola is always going to extend to the right and to the left, and therefore eventually hit the y-axis, that also has implications for domain and range. But we're going to get to those things in a different video. Something to think about, though. Okay. So what I've got from these 4 examples is some evidence, and I'm telling you that the evidence holds true, that this is always going to be the case, that every quadratic function, I'm just going to abbreviate for the sake of time here, quadratic function, has exactly one y-intercept. Okay, and again, I'm going to abbreviate just for sake of time. Okay, every quadratic function has exactly one intercept. But look at the y-intercept, or the x-intercepts. This one, where the graph is touching the x-axis, there are 2. This one also has 2. Now, if you think about the general shape of this graph, is it possible for it to ever have more than 2? Well, no, it's not, right? The shape of this graph, because it has 2 parts to it, it's got the right part and the left part, whether they're going up or whether they're going down, it still just has those 2 parts. So it'll never have more than 2 x-intercepts. But notice this one, it comes down and the vertex happens to be sitting exactly on the x-axis. So in that case, there's only one place where the graph touches the x-axis. It's right at the very bottom of the parabola, at the vertex. So I might have 2, but I might only have 1. And notice this one right here, gracious sakes, the vertex is below the axis and the parabola is concave down. So in that scenario, there's no x-intercepts. Not real ones anyway. This is a scenario last semester where we would have talked about that it has imaginary solutions. But when we talk about functions, in our class anyway, we're not ever going to talk about imaginary numbers as being part of our domain or our range. And so therefore, we would just say this simply does not have any x-intercepts. So what we've got is that the most it can have is 2. It might only have 1. And there's a chance it won't have any. And so that becomes our final, or our second statement here. Every quadratic function has between 0 and 2 x-intercepts. And when I say between 0 and 2, I mean including 0 and 2, right? It could be 0, it could be 2, it could be 1. So when I say between 0 and 2, I include 0 and 2 as part of the options. Okay, so if you want to write that a slightly different way so it makes more sense when you're reviewing your notes to study or what have you, or for the quiz, the options are it could be 0, it could be 1, or it could be 2. Those are your options. Okay, so we know now how many there may be for x-intercepts and how many there may be for y-intercepts. But the learning objective for this video is to actually find them. So let's get to that. How do you find, let's begin with y-intercepts. They tend to be a little bit easier to find. And this is something when we studied lines we talked a little bit about. So again, I'm just going to draw a quick sketch for a second and think about, for any parabola, for any graph at all, whether it's a parabola or not, really doesn't matter. For any graph, if it actually does touch the y-axis, like this one does, all our parabolas will, right? We just said that. Think about what will be true about that point. And it doesn't matter if the parabola is opening up or opening down. As long as there's a y-intercept, which we said it will always be, there's going to be something true about that point, okay? When we think about the coordinates, notice because I'm on the y-axis, I haven't moved to the right, I haven't moved to the left, I've only moved up. So what will the x-coordinate be? Well, if I'm exactly on the y-axis, the x-coordinate is going to be 0. And that's true here too. I didn't move to the right, I didn't move to the I didn't move to the right or the left, I only moved down. So same thing, I'm going to have a negative y value, but the x value is going to equal 0. And that's always true for any point that's on the y-axis. So if that's always true, then the way you find the y-intercepts is you use the fact that x will equal 0. In other words, you just substitute that into your equation. So let's look at an example. Example number 1, find the y-intercepts of, and here's our equation, y equals 3x squared plus 2x minus 5. Okay? Y equals 3x squared plus 2x minus 5. So what I'm suggesting is we know that x is going to equal 0. So if I just simply take the equation And as we've said in our class, when we substitute something in, we're going to replace the variable with parentheses, and then we're going to plug that number in, 0, 0. Oops, I forgot the 2, right? It was 2x, so 2x. There we go. So x is equal to 0, so I'm plugging those numbers in, and now I just simplify. Well, 0 squared, 0 times 0, that equals 0. And 3 times 0, that equals 0. 2 times 0, that equals 0. 0 plus 0 equals 0. Minus 5 is a negative 5. Okay, and so that's how we find the y-intercepts. Now, I will say I do have students who approach this 2 different ways, and both are acceptable and fine, and you're welcome to do it either way. When I say use the fact that x equals 0, some students interpret that as doing exactly what we've done here, plug in 0 and then simplify. But some students recognize if I'm plugging in 0 for x, this whole thing and this whole thing are always going to equal 0. They're always just going to simply turn into a 0, because when you plug in 0 for x, 0 times 0, 0 times any number always equals 0, and 0 plus 0 always equals 0. So you're going to be left with just this piece at the end. And so what happens, and what some people recognize and they use as a shortcut, is whatever this number is at the end, that is going to be your y-intercept, right? It's exactly the same if you think back when we were doing back in the day, I can't spell, when we were doing linear functions and it was y equals mx plus b, what did we say was going to be the y-intercept there? We said it was going to be the thing at the end of the equation, because if you plug in 0 for x, you just get 0 plus b. So y equals b. It's the exact same thing here. The only difference is we don't call it b anymore. Now we call it c. So you can plug in 0 for x and you can simplify, and that works. And that works for all functions everywhere, all the time. It never fails. But if you recognize the fact that just simply the value of c is going to be your y-intercept, that gives you a shortcut. And that's perfectly fine and acceptable to do. Whichever way you prefer, I could maybe jot that down as a note. So use the fact that x equals 0, either plug it in, either substitute it in, or recognize that the c value will equal the y-intercept. And both of those are based on the fact that x equals 0. So whichever way you want to do it is perfectly fine. But that takes care of y-intercepts. Let's talk about x-intercepts. Of all the 5 different parts of the parabola that we have talked about in these videos, the x-intercepts are definitely the hardest ones to find. Okay, now the way you find it is the same basic concept. It does not matter if there's exactly one x-intercept, like a parabola that goes this way, or if there are 2 x-intercepts. So maybe my parabola goes this way. Okay. In either case, it doesn't matter. What happens is the x-intercepts are exactly on the x-axis by definition, which means I've only moved right, or left, but I have not moved up or down for any of those. And if I haven't moved up or down at all, then that means in every single one of these scenarios, the y coordinate equals 0. Okay, so we're going to use that fact. Use the fact that y equals 0. Okay, so when we're doing y-intercepts, x equals 0. When we're doing x-intercepts, y equals 0. It's always the opposite one. The other one is the one that equals 0. Okay. So if we think about an equation, x squared plus 5x minus 6 equal to f of x. And we want to find the x-intercepts. This takes us back to actually one of our major topics from last semester. If I'm going to say that the y is equal to 0, remember, f of x is the same as y. That's the same as having a y. So we're going to make that be equal to 0 is what we're going to do. Everything else stays the same. And then we're going to solve for x. Now, if you think about last semester, that was a major, major topic. There were a few different ways that you could solve these for x, but none of them were particularly short or simple. Okay, so what we're going to do, use the fact that y equals 0, that means plug in 0 for y, or in other words, set the equation equal to 0 and solve for x. When I plug in 0 for y, that just makes the equation equal to 0. And now I'm going to solve for x. And there were a few different ways that we did this, but if I remember last semester, when we got to the end of this unit last semester, there were really two main ways that people used. Some people like to use square roots, but that was something that you couldn't use all the time. It was an exception. So most people either factored or they used the quadratic formula. Either one, okay? Now, we don't have the time to go back right now and reteach those in their entirety. So there are videos over both of these from last semester that you may want to go back and review. But I will give you a couple little reminders right now. First of all, remember that factoring, this does not always work. It only works when the answers turn out to be nice, pretty numbers. But sometimes the answers are not nice, pretty numbers. It doesn't always work. If it works, it tends to be faster and easier than the quadratic formula. But it doesn't always work. The quadratic formula, on the other hand, always works. So I also seem to remember from last semester that some of you in our class preferred to just always use the quadratic formula because you knew it was going to serve you well. It would never, ever fail. All right. So again, if you need review of how these work, I'm going to suggest you go back and find those videos. Maybe I'll put a link to those videos in the description for this video so you can find them easily. But go back and watch those videos for review if you need to. What I'm going to do as the balance of this is I'm going to just simply do quickly. So you might need to pause this or watch it in slow motion or something, but I'm going to quickly review these so that way you've just got something just as a reminder. And if you need more than that, you're going to have to go back and watch those videos. All right, so factoring. The method for factoring that we used was called grouping. And with grouping, you had to have 4 terms. And so the way that that worked for us was we recognized that in front of x squared was a sneaky ninja 1. And we multiplied the number in front of x squared by the number at the end. So 1 times 6, that was equal to 6. When we multiplied those, we ignored the signs. Then we found all the factors of 6, 1 and 6, 2 and 3. In this case, that's all there is. Then what we did was we picked the factored pair that would do this thing. So in this case, subtract to equal that number. So in this case, 5. So which of these things subtract to equal 5? Well, it's these two, right? 6 minus 1 equals 5. Now, this is the only time I care about the sign. Specifically, I want it to be a positive 5. So that means I cannot do 1 minus 6. 1 minus 6 would be negative 5. I have to do 6 minus 1. That's going to give me a positive 5. So I'm going to break this 5x up and rewrite it as being a 6x minus a 1x. Okay, now the other pieces are still there. There's still a 1x squared at the beginning. There's still a minus 6 at the end. They haven't gone anywhere. It's still equal to 0. That hasn't changed. Okay, then what we did was we looked at the two groups. This is why it was called grouping. and we found the greatest common factor for each of those groups. But even this had a shortcut. In the first one, I just take out my greatest common factor, which is x. In the second one, we knew the things that were left behind had to match. So I could just write the parentheses down and do a quick division to see what it was I had to factor out. -6 divided by +6, -1 must have been what I factored out. And so, whoops, 0 goes on this side. The things on the outside of the parentheses become one set of parentheses, and the things on the inside of the parentheses become the second set of things, and that's my factorization. To finish solving, we took each one of those and set them equal to 0, and then we solved those equations for x. And so this particular thing does have two x-intercepts. They're at 1 and at -6. 1 and -6 are my two x-intercepts. So for example, number 1, find the x-intercepts. The answer is 1, 0. That would be one of the points. And -6, 0 would be the other points. Now, why is it 0? Where's that coming from? That comes from the fact that we know we're on the x-axis. Whoops, you can't see what I'm pointing at. We know that we're on the x-axis. So in this case, I guess we've got 1, 0, and -6. So that would be kind of sort of like this, right? There's my -6, 0. There's my 1, 0. It would be something kind of like that. There are my x-intercepts. Okay, so there we go. That's just a very, very fast review of doing it with factoring. Okay, now I'm going to do one more, just a very, very fast review again with the quadratic formula. So here's example number 3. Again, finding x-intercepts. This time we're going to use the quadratic formula to do or find the x-intercepts of this. So x squared, let's, you know what? Let's just do the same one. We know what the answer is going to be because we already did it, but let's just do this with the quadratic formula. So use the quadratic formula this time. Okay, so with the quadratic formula, the first thing we had to do was find a and b and c. That was the first thing we had to do. And then we recognized that our formula said that the x-intercepts will be the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And what we did was first we found the answer for the stuff inside the square root. That was called the discriminant. So b squared minus 4ac. In this case, b is equal to 5. So 5 squared, remember parentheses are important. A is equal to 1, and C is equal to -6. So this will give me the value of my discriminant. 5 squared is 25. 4 times 1 is 4 times -6 is a -24. So I'm going to have minus a negative shum shum 24. And 25 plus 24 gives me 49. So that's the value of my discriminant. So this whole thing in red becomes a 49. Now the rest of my formula is still here. I haven't done anything with the rest of this yet. So I've got the opposite of b. B was equal to 5, plus or minus the square root, of this stuff, which turned out to be equal to 49, all divided by 2 times a. 2 times a is equal to 1. And so now we simplify this. Again, using order of operations, working on the top and the bottom. Square roots technically come first, so the square root of 49, that's equal to 7. And then I've got to do opposite signs because that's like a multiply. So negative, opposite of 5 is a -5. 2 times 1 is equal to 2. Okay. Now remember, this represents two different problems. There's a plus and there's a minus. So a -5 plus 7 is one of the problems that I'm doing, and a -5 minus 7 is the other problem that I'm doing. So -5 plus 7 gives me a -2 over 2, which equals -1. And -5 minus, I'm sorry, -5 plus 7 is a +2. Oops, My mistake there. Make sure you've got the right thing. Positive 2. Positive 2 divided by positive 2 is a positive 1. My mistake there. Okay, now, negative 5 minus 7, that's a negative 12. Divided by 2 gives me a negative 6. And so notice we got the exact same answers from that as we did when we factored. 1 and negative 6. 1 and negative 6. Okay? So some students, when we did this last semester, they preferred to use the quadratic formula. Other students preferred to do factoring if it worked. But remember, factoring doesn't always work, so you still have to have the quadratic formula as a backup plan. And then there was another method called using square roots, which we used only rarely. And that method still works sometimes, but these work as well. So that is going to take care of this particular video. We've done 2 methods for finding x-intercepts. We've done 2 methods for finding y-intercepts. We talked about the fact that there would always be 1 y-intercept and there might be 0, 1, or 2 x-intercepts. And that takes care of the learning objectives for this video. So thanks for watching. Have a good one.